Here is another example of the problem where two things change. I bought a number of softballs for my team and spent $80. A sale started the next day and the price per ball dropped by $1.50. At the sale price, I could have bought 12 more balls for the same amount of money. What was the original price before the sale for each softball? The first thing I do is to identify the two things that changed. One of them is the price, which dropped by $1.50, and the other is the number of balls, which increased by 12. One of the two things that changed is what is being asked for in the question at the end of the problem. What was the original price for each softball? I use that thing that changed to define both of my variables in terms of x. X will be the original price per ball, and therefore x minus 1.5 or x minus $1.50 is the sale price. Building my equation, the other thing that changed, the number of balls increasing by 12, goes right here to the right of the equals. I have to create two fractions. The bigger fraction minus the smaller fraction will be equal to 12. Because the unit of measure of 12 is number of balls, I have to find a way to make each of these two fractions have the same unit of measure. Since I spent $80, if I divide the $80 by the price per ball, that converts the entire fraction so that it has the unit number of balls. Because I'm subtracting in my binomial, I put it in the first fraction. This allows me to make sure that the answer I get when I divide the first fraction will be bigger than the answer I get when I divide the second. Because dividing 80 by a smaller number gives a bigger answer. I know my equation will work. Now I'm going to simplify the equation. Because the variables are in the denominator, I am going to multiply everything in the equation by both x and x minus 1.5. And it looks like this. It's time to do some canceling. In the first fraction, the x minus 1.5 on the top cancels with the x minus 1.5 on the bottom. In the second fraction, the x on the top cancels with the x on the bottom. Then I do my multiplication on the left of the equals. All I have in the first fraction is x times 80. That gives me 80x. In the second fraction, I have 80 times x, which gives me another 80x. That is subtracted because of this minus sign. And 80 times negative 1.5, which would give me negative 120. But because I am subtracting negative 120, it turns into plus 120. And of course, the 80x minus 80x also cancels. The left side of the equation was very complicated looking all along, and now after all this canceling, all that's left there is the 120. Meanwhile, the right side of the equation only had a 12 at first, but once I multiply that 12 by the x and the x minus 1.5, I end up with a more complicated side of the equation, 12x squared minus 18x. Now it is easy to use algebra to convert this into a quadratic equation, and I will find the roots of the quadratic equation in order to find the answer to my question. First thing I want to do now is simplify this equation if I can. If I divide everything in the equation by 6, I convert it into 0 equals 2x squared minus 3x minus 20. I have smaller numbers to work with. Now I get to choose between factoring or using the quadratic formula to solve this problem. And this time I choose to solve it with factoring. I see a factorable complex trinomial here. I define my a, b, and c, and I find my ac. And I am asking which two numbers multiply to give ac, negative 40, and add to give b, negative 3. Those two numbers are 5 and negative 8. I go through the procedure of factoring the complex trinomial, replacing b equals negative 3 with 5 minus 8. Once factored, it gives me 0 equals x minus 4 in brackets times 2x plus 5 in brackets. And now I do the split. I make each of these binomials equal to 0. And I simplify. And I get x equals 4 and x equals negative 5 halves. I throw away the negative answer and therefore what I defined x as at the beginning of the problem must be equal to 4. Since x was the original price per ball, that means the softball originally cost $4. We can verify if this makes sense. If the original price per ball was $4, that means the sale price, being $1.50 cheaper, must have been $2.50. If the original price per ball was $4 and I spent $80, I would get 20 softballs. If I bought them at the sale price instead, spending $80, I would get 32 softballs. So therefore it's true that the number of balls would have increased by 12. This is an example of using quadratic math to solve the problem where two things change.